You know, it's one of the biggest we've ever held, but I think what I'm really looking forward to is the idea that we have such a mixture of people who are relatively new in the field and people who are more experienced. And I think the exchanges that will take place here between those two groups, including some of the junior researchers, will be really, really promising. The International Permafrost Association has existed now since 1983, so that's a pretty long time, and it started out as a small group, the 4 countries that have most of the permafrost in the world, so that's Canada, the United States, China, and what was then the Soviet Union. Now we're 26 countries, and the big enlargement that's taken place has been particularly in Europe. So what we're seeing is a lot of other countries that don't have permafrost still think it's a really important topic, and the IPA is there to help guide, not to do research directly, but to help facilitate research and make sure that we can get into international agreements as much as possible. We've learned that permafrost is changing all the way around the Arctic, all the way around the world, and we can't just have it all happening within single countries. We need organizations to help research take place in multiple countries at the same time, using the same techniques to provide really the best answers we can. I'm going to be presenting here. I have a paper a presentation about using geophysics and electrical techniques to look at changes in permafrost in northern British Columbia and the southern Yukon. This is an area where the permafrost is barely hanging on. It's like just holding on by its fingertips. The ground is at a temperature of about -0.1 or -0.2. So it's precisely the areas where we might expect change to be taking place, permafrost degrading, permafrost thawing. And indeed, that's what the results we have show. And in fact, there aren't very many studies that really measure and show that change. So I'm excited to show that work. Because it's invisible. So it's not like glaciers, it's not like sea ice, you can't reach out and touch it, it's under the ground. So we have to understand, it's more complicated than those subjects, so we have to understand it and communicate it as well as we possibly can, because it's not actually that easy to communicate about something that you can't see or touch. There are multiple impacts of thawing. The first thing is that you might see a road that has big bumps in it and cracks along the side, and that will cost a lot of money to fix. And then it also plays into the environment in general, so we might get large exposures, large landslides that take place, some of them happening without any knowledge in advance that they were going to happen. And it can change the way rivers run as well over the long run. Well, people live in homes, and if the homes aren't built properly on permafrost, then over time they will degrade and they will sink. And basically they have to be abandoned in the long run if they're not built properly. So we do kind of know how to do it, but we know how to do it if the permafrost stays there. Our biggest problem is what to do if the permafrost is thawing. Then it's very hard to build anything on it. Perhaps in some cases you're better off trying to get rid of the permafrost in advance of building, and we know some ways to do that. So when it's really almost on the point of going, sometimes it's better just to give it a little push and then build on it when it's thawed, just like we do everywhere else in the world. Or we can try to keep it frozen. When it's a little colder, we'll try to keep it frozen with technological solutions. I know that in the Yukon, the last 100 kilometers of the Alaska Highway near the border with Alaska itself has permafrost beneath the highway. That permafrost is thawing, and it costs a huge amount to keep the highway in a reasonable condition. So we have direct comparisons to say it will cost a lot of money. In other places, the costs are maybe hidden because they're to do with maintenance of housing, which would need maintaining anyway. But there's no question that basically in Canada at least and elsewhere where taxpayers pay for public infrastructure, there's a cost associated with changing permafrost in the future. The developed countries Most of Canada is not in the permafrost area. Most of Russia is not in the permafrost area, and the same thing, Alaska is one part of the US. The answer is we can afford to deal with it. But there may be other countries where it will be harder. For example, Nepal has permafrost at high elevations, but that's a poor country. And as that changes, there may be more landslides, which cost a lot on roads. So they will have a far harder time dealing with permafrost change than we do in the developed world. I think it's not just that, it's also that we think permafrost now has a global reach. So, I've been working on it for 40 years. When I first started working, the only people that cared about it were permafrost scientists. Now we understand that permafrost change will not just affect me and what I want to study, but everybody who's watching this broadcast, because it's likely to put greenhouse gases into the atmosphere, which themselves will cause further climate warming.